Alright, Mr. Ayers back with you here. This is lesson 4.3, talking about compound inequalities. Okay, so more than one inequality smashed together into one. That's what we're doing here. So your two objectives are to write, solve, and graph compound inequalities, which is kind of actually three objectives in one, and then to model real-life situations with compound inequalities. Alright, let's get started. First of all, we got two types of compound inequalities, kind of like a battle royale here. We got and inequalities versus or inequalities. Alright? And the difference is really easy. Okay, there's some things you got to know about them. The difference is really easy to see though. Okay, and inequalities, the solutions must satisfy both parts. Okay? So it's got to be true for one part and for the other part. Or inequalities have solutions that must only satisfy one part. Okay? This or that sort of thing. So an and inequality, I'll write you an example here. That's what an and inequality looks like. Okay, so this says -1 is less than or equal to x, and x is less than or equal to 4. That's how I would read this. Okay, so here's like two inequalities in one. So here's the first one. -1 is less than or equal to x, and x is less than 4. So numbers, okay, answers to this must satisfy both parts. So the number has to be greater, or the number has to be in here. It's got to be bigger than or equal to -1, because -1 has to be less than it, and it's got to be less than 4. So an example would be like 2. Okay? Or we could have 0, or 1, or 3. Okay? -1 would also work for this because it says -1 is less than or equal to x. So -1 is less than or equal to -1. -1 is less than or equal to 0, and so on. But x has to be less than 4. So 4 would not work for an answer, but like 3.99 would. Okay, so that's what an and inequality looks like. And they both have to be, the solutions, whatever numbers you plug in for x, have to fill both of these parts. An or inequality is really easy to read and understand. Okay, it looks something like this. X is less than 1, and you'll see the word or x is greater than 7. Okay, so think about numbers that would satisfy this. X is less than 1 or x is greater than 7. Well, 0 is less than 1 or greater than 7, okay, because it's less than 1. 8 fills this because it meets the second criteria over here. So or has solutions that only need to work for one of the two inequalities. So 0 and 8 would both be solutions to that, even though 8 isn't less than 1, okay, but it's only got to fill one or the other. Alright, now let's move on. Okay, now we need to know how to graph compound inequalities. Okay, so again, this is really like graphing two inequalities in one. So your steps, number one is to make a number line. It should say that extends. Okay, so this should say that extends past both numbers representing the inequality. So my lowest number is -12, so I've got to go one number past that. And my highest number is -8, so I've got to go one number past that. So my number line is going to go from -13 to -7. So here's -12, -11, -10, 9, 8, and 7. Okay, and we're going to number our entire number line. Okay, so that's step one. Again, notice I included numbers that are on the high and low end of these numbers right here. Alright, step two is to put the correct dots on the numbers represented by the inequality. Okay, so it says right here that -12 is less than or equal to x. So that means at -12 I need a closed dot. Then it says x is less than or equal to -8. So at -8 I need a closed dot. Okay? Now, step 3 says to shade the region of numbers that is satisfied by both inequalities. Okay? Well, negative 12 is less than or equal to x. Okay? So that means x has to be bigger than negative 12. So that means I would need to shade this way for this inequality. Okay? So I'm going to shade toward the bigger numbers. I'm going to actually do that here. Let's get a different color. So I would shade this way for that inequality. Okay? Well then for the other inequality, x is less than or equal to negative 8. So that means I'd start at negative 8 and shade this way. Okay? My solution to this shading, where I'm actually going to shade on my number line, is the spot that includes both of those shadings. Okay? Because again, and inequalities have to satisfy both of them. So the stuff that satisfies both inequalities is where the lines are overlapping themselves. So that's going to go right in here, in between them. So there's my shading. Okay? And to check if I did this correctly, pick one of the numbers that's in your solution region. Okay? So let's say negative 10. If I plug negative 10 in for x, then it should fill both of these inequalities. Well, negative 12 is less than or equal to negative 10, and negative 10 is less than or equal to negative 8, so it works. Okay, so these numbers in here should all fill that inequality. Okay, let's try an OR here. Alright, sorry. So yeah, make a number line that extends past both numbers. Well, I've got to go from 10 to negative 10 here, okay? So let's be smart about this. You don't need to put every single number in between them. So let's say I want to count by 5s. Sounds reasonable. So I'm going to start out here at negative 15 and go negative 10, negative 5, 0, 5, 10, and I got to go past 15. That's perfectly acceptable. Now put dots on the numbers represented by the inequality. It says x is greater than 10, so I need an open dot at 10. And x is less than negative 10, so I need an open dot at negative 10. Okay? So again, now I'm going to pick where my shading would go. Well, x is greater than 10, that shading would be this way. Or x is less than negative 10, that shading would be that way. For an OR inequality, it's only got to be one or the other. So I'm going to shade both parts for an OR inequality. Okay? Because the only numbers that aren't solutions of one or the other are in here. Okay, 0 is not greater than 10, and it's not less than negative 10. So these numbers in here don't work. But if I go out here, negative 15 isn't greater than 10, but it is less than negative 10, so it fits one or the other. Same thing out here, 15 is greater than 10, even though it's not less than negative 10, it fits one or the other. So those work for both. Okay? So notice, almost all the time, and inequalities are going to be shaded in the middle here. Okay, this might be a good thing to write down. I'm not going to, but you may want to write this. And inequalities are almost always shaded in the middle. Okay? Or inequalities are almost always shaded on the outside. Okay? Almost always. We'll talk about a couple special occasions when that's not the case. Alright? Let's move on to some more examples. So again, here we are on the next side of the stuff I just said that you might want to write down. So, graphs for and compound inequalities typically have shading that intersects the middle of your dots. Okay? So again, those graphs, if here's my number line, and here's my dots, that shading is going to be right here in the middle. Okay, for and inequalities. And the numbers where the shading intersects, okay, right here in the middle, those are the solutions. And graphs for an or inequality are typically going to have shading that don't intersect. So the shading is going to look like this. Okay? And any numbers that are shaded are solutions to an OR inequality. So any numbers out here and any numbers out here are solutions. Okay? Let's talk about solving them now.